Hi everyone, in this example I'm going to do a projectile that is launched at an angle and falls to a height other than where it was launched from, or to a level other than where it was launched from. So to get things started, we'll just create a little projectile here. We're going to shoot it up at an angle of 40 degrees from the horizontal. No, excuse me. Mistake in the first minute. 60 degrees from the horizontal at 40 meters per second. Make a little guy kicking it. And the ball is going to be 20 meters above where it's going to land. So it's going to kind of go up and land down here. First step is we're going to try to organize our information by doing a little chart that we've been doing. So X and Y and up and down. And to get the X and Y velocities, we need to do the components of 40 meters per second. So I'm going to do that over here. Vx equals V cosine theta. Vx equals 40 cosine 60. Vx equals, that turns out to just be 20. If I do Vy, Vy equals V sine theta. Vy equals 40 sine 60. And Vy equals, I think it comes out to be rounded 34.64 meters per second. So the Vx value of 20 goes in the x column, 20 meters per second. There's no acceleration in the x direction. It's 0 meters per second squared. The distance traveled in the x direction is what we'd really like to find. That's the range. And the time in the x direction is also unknown. Write that again. Time is unknown. In the y direction, the initial velocity is 34.64. The final velocity is 0. The acceleration is negative 9.8 meters per second squared. The distance up is unknown, and the time up is unknown. Going down, the initial velocity is 0 because we're starting from the highest point, the peak. The final velocity is unknown going down because we don't know. It goes down further than what we kicked it from. The acceleration going down, this is a personal choice. You can use positive or negative. I'm going to use negative 9.8. So I'm going to try to stick with the coordinate system that says anything that's going up is positive, anything that's going down is negative. And then my distance down is going to be whatever the distance up is, and then we're going to add on 20. So we're going to hold off on writing that, and I'm going to show you how to write that, and then the time down. So over here, we're going to start by finding the time. The time is the key to these problems, so I'm going to find the time up first. Find the time up. If I look at everything that I have, if I use the equation Vf equals Vi plus A times T, T equals Vf minus Vi divided by A, time equals 0 minus 34.64 divided by negative 9.8. If you do that calculation out, you end up getting 3.53 seconds. Plug that in here, 3.53 seconds. Now, it would be tempting to multiply that by 2, but you shouldn't do that because up is not equal to down. So the next thing I'm going to do is I'm going to, and there's different ways of doing this problem, but I'm going to find the distance up. That way I can find the distance down. The distance up, I'm going to use this equation, d equals VIT plus 1/2 AT squared. D equals 34.64 times 3.53 plus 1/2 is negative 9.8. It's going up. Times 3.53 squared. And the distance up is 61.22 meters. 61.22 meters. So if I go up 61.22 and then I have another 20, altogether the distance down is 81.22, But because I'm saying that down is negative, my displacement down is actually negative 81.22. So because if you go from highest point to lowest point, that is in the negative direction. The displacement should be a negative 81, and that's how we have to write that. Let me clear that up because I wrote it a little messy here. I can rewrite it. Negative 81.22. Now we can find the time down. Time down. Sorry for the messy handwriting. Let's see. I'm going to use the same equation. D equals VIT plus 1/2 AT squared. There is no initial velocity down, so the time down is equal to the square root of 2D divided by A. T equals the square root of 2 times, let's use the down distance, negative 81.22 over negative 9.8. That's the acceleration down. And you can see why the negative for the displacement is so important, because if we have a negative acceleration and we divide that into a negative displacement, we'll get a positive time. And we're going to end up getting 4.07 seconds. That's 4.07, which makes our total time 3.53 plus 4.07. So it comes up to 7.6, I think. Is that right? Just double checking, I think so. 7.6 seconds, close enough. And finally, we can find the range if we know, this is in the x direction, if we know the time. Distance in the x direction, or displacement, VIT plus 1/2 AT squared. There's no acceleration. My velocity is 20 times 7.6. And your range in the x direction is, it's about 152 meters. There's some decimal and rounding things that can happen there, but it's 152. So there you have it. To summarize, first find your x and y components, organize your information, find time up, time down, add them together for the total time, and then you can find the range. So I hope that helps a little bit with the problem of projectile that lands at a different height than where it started.